10 mind-blowing facts about black holes. Number 10. They aren't actually holes. Despite their name, a black hole is not an empty space or a portal to another dimension in the classic sense. It is, in fact, an unimaginably large amount of matter compressed into an extremely small space. Imagine taking a star several times more massive than our Sun and crushing it down to the size of a city. The result is an object with a gravitational field so intense that nothing, not even light, can escape its pull once it crosses a boundary known as the event horizon. This horizon is not a physical surface you can touch, but rather a point of no return. Once something crosses it, its fate is sealed, and it will be pulled toward the center of the black hole. This is why they are black. They do not emit or reflect any light, making them the darkest objects we could conceive of in the universe. Seeing a black hole directly is impossible. We can only detect its presence by the way its gravity affects the stars, gas, and light surrounding it. Number 9. They are not cosmic vacuum cleaners. There is a popular myth that portrays black holes as cosmic vacuum cleaners, indiscriminately sucking up everything around them. However, this isn't entirely true. A black hole obeys the same laws of gravity as any other massive object. If we were to replace our Sun with a black hole of the exact same mass, Earth and the other planets would continue to orbit it just as they do now. We would not be pulled in. The real danger of a black hole lies in its proximity. Its immense gravity only becomes inescapable at a relatively close distance, beyond the event horizon. This means a spaceship could theoretically orbit a black hole at a safe distance without being swallowed, much like satellites orbit Earth. The issue isn't that it sucks, but that it warps space-time around it so extremely that if you get too close, all possible paths inevitably lead to its center. Number 8. The infinite stretch, or spaghettification. If you were to fall into a black hole, you wouldn't be instantly obliterated. Instead, you would experience one of the strangest and most terrifying phenomena in physics: spaghettification. As you approach the black hole, the gravitational force acting on the parts of your body closer to it would be much stronger than the force on the parts farther away. For example, the gravity pulling on your feet would be exponentially more intense than the gravity pulling on your head. This difference in gravitational force, known as a tidal force, would stretch you vertically while compressing you horizontally. Your body would be elongated further and further, like a noodle of spaghetti, until you were ultimately torn apart, atom by atom. This process of extreme stretching is how a black hole dismantles stars, planets, and any other matter that dares to cross its event horizon, turning it into a stream of particles before consuming it. Number 7. They are natural time machines. According to Einstein's theory of relativity, gravity can bend not only space, but also time. A strong gravitational field causes time to pass more slowly. Since black holes possess the most extreme gravity in the universe, they are also the most powerful time machines in existence. If you could orbit near the event horizon of a black hole for a while and then return to Earth, you would have aged much less than the people you left behind. This effect is known as gravitational time dilation. For you, time might have passed as just a few years, but on Earth, decades, centuries, or even millennia could have elapsed, depending on your proximity to the black hole and its mass. This means that black holes theoretically offer a one-way trip into the future. While you couldn't return to the past, you could leap forward in the universe's timeline simply by harnessing the way these cosmic monsters warp the very fabric of reality. Number 6. The spinning giants of the universe. Not all black holes are static. In fact, most of them spin, and some do so at mind-boggling speeds. When a massive star collapses to form a black hole, it conserves its angular momentum, causing the resulting black hole to rotate. As the black hole pulls in more matter, like gas and stars, it can spin faster and faster, approaching the maximum speed allowed by the laws of physics, the speed of light. This spin has profound consequences. A rotating black hole doesn't just pull everything toward its center. It also drags the fabric of space-time around with it in a phenomenon called frame dragging, or the lens stirring effect. Imagine a planet spinning in a pool of honey. The honey near the planet would be dragged along by its rotation. Similarly, a spinning black hole forces space itself to rotate with it. This creates a region called the ergosphere, where it is impossible to stand still. Space itself forces you to move. Number 5. The deepest sound in the cosmos. Although sound cannot travel through the vacuum of space, black holes are not completely silent. In 2003, astronomers using NASA's Chandra X-ray Observatory detected something astonishing coming from a supermassive black hole at the center of the Perseus galaxy cluster. The black hole was emitting pressure waves, or sound waves, through the hot gas surrounding it. These waves were the result of enormous explosions of energy emanating from the cosmic giant. These sound waves are, in fact, a musical note. However, it's a note that no human will ever hear. Its frequency is a B-flat, but it is about 57 octaves below middle C on a piano. This makes it the deepest note ever detected in the universe, with a period of oscillation of nearly 10 million years per cycle. It's a reminder that the most violent phenomena in the cosmos can generate a form of music on a scale that defies our comprehension. Number 4. They come in all sizes. Black holes don't come in just one size. They exist in an astonishing range of masses, from the small to the colossal. The most common are stellar mass black holes, which form when a very massive star dies. They have a mass of up to about 20 times that of our Sun, but are compressed into a sphere only a few kilometers in diameter. Our own Milky Way galaxy could contain as many as 100 million of these stellar black holes. At the other end of the spectrum are supermassive black holes. These giants reside at the center of nearly every large galaxy, including our own. Sagittarius A, the black hole at the center of the Milky Way, has a mass of more than 4 million suns. Others can be even larger, reaching billions of solar masses. Scientists are still not entirely sure how these monsters form, but their immense gravity is the anchor that holds entire galaxies together. Number 3. They slowly evaporate. One of the most revolutionary ideas about black holes came from physicist Stephen Hawking. He proposed that, contrary to the popular belief that nothing can escape them, black holes actually lose mass and energy over time through a process known as Hawking radiation. This phenomenon is based on quantum physics, which suggests that the vacuum of space is actually filled with pairs of virtual particles that constantly pop into and out of existence. When one of these particle pairs appears right at the edge of the event horizon, it's possible for one particle to fall into the black hole while the other escapes into space. From the perspective of an outside observer, it would appear as though the black hole has emitted a particle. By emitting this radiation, the black hole loses a minuscule amount of its mass. This process is incredibly slow for large black holes, taking longer than the current age of the universe for them to completely evaporate. However, it demonstrates that not even the most indestructible objects in the cosmos are eternal. Number 2. The point where physics breaks down. At the heart of every black hole lies the greatest mystery of modern physics, the singularity. This is the final point to which all matter that crosses the event horizon is pulled. According to our current theories, the singularity is a point of zero volume and infinite density. Here, the entire mass of the black hole is compressed into an infinitesimally small point, and the laws of physics as we know them, including Einstein's general relativity, simply cease to function. The singularity represents the limit of our knowledge. At this point, gravity becomes infinitely strong, and space-time curves to infinity. To truly understand what happens at a singularity, physicists need a theory that unites gravity with quantum mechanics, a theory of everything that we do not yet possess. Solving the riddle of the singularity would not only tell us what's inside a black hole, but could unlock the deepest secrets about the origin and fundamental nature of our universe. Number 1. They contain all the information in the universe. This is perhaps the most mind-bending and controversial fact. The holographic principle is a speculative but powerful idea in theoretical physics, suggesting that all the information contained within a volume of space can be described by a theory that lives on the boundary of that region. Applied to black holes, this leads to an astonishing conclusion. Everything that falls into a black hole, whether a star, a planet, or an astronaut, is not simply destroyed, but its information is imprinted or encoded onto the two-dimensional surface of the event horizon. This idea attempts to solve the so-called information paradox, which asks what happens to an object's information when it's consumed by a black hole. Some physicists take this concept even further, suggesting that our own three-dimensional universe could be a holographic projection of information stored on a distant, two-dimensional surface. If this is true, black holes are not just strange objects in the cosmos. They are natural laboratories, showing us that the reality we perceive might be an illusion, a complex hologram on a universal scale.
Thank you for watching our video. Subscribe to our channel for more videos like this. Give it a like, comment your thoughts, and share this video with your friends and family.